of the magnetic force, measuring magnetic field. So this is what is the value of the B at the midway, meaning at the center of the, or between the two wire here. So meaning this is a 12 cm, meaning this is half of 12, this is 6 cm, and this is also 6 cm. Because of to find the magnetic field for the current carrying in the straight wire, so you have the equation for B produced by the current wire 1's 3.5 ampere is equation is nu naught I over 2 pi r. So at the point, at the midpoint here, you have a 2b. The first b is come from the, if you use the right hand, so direction of the b here is a out page, and this is into the page. For the second wire, the direction to current direction downward, meaning the direction of the B produced by the current wires 2 is also into the page, meaning at the midpoint here you have a 2B. The first is B produced by the current one, right? And the second B or B2 is produced also into the page, produced by the second wire. So we need the total B at the midpoint is equal to nu naught for the current I1 and divided by 2 pi. This is distance at the midpoint to the first wire and second wire is the same value. This is 10 cm, or you convert to the meter is -2, and plus, because you must have a total here B, and produced by the B by the second wire is the same equation, nu naught current 3.5, but the direction of current downward, and 2 pi, and the distance is also 6 exponent -2. So now the nu naught is constant. Nu naught is constant is 4 pi exponent -7, and the current I2 is 3.5, also I1 is also 3.5. So meaning the total B, you can find the total B is equal to 2.33 exponent -5 Tesla. And direction, because for the B1 and B2 is the same direction into the page, Number 2, calculate the magnitude of net force per unit length experienced by the wire. As you know, if you have the two wire here, meaning you have a magnetic field produced by the wire 1 on the wire 2, and the same process, magnitude produced by wire 2 on the wire 1. So meaning you have the force for the wire 1 and wire 2. So if you want to calculate the net force per unit length, so this is equation, force per unit length. The equation is a nu naught constant, the magnitude of the current I1 and current wire, let's say I2, and divided by the distance between the two wire is 12 centimeter. You must use the, this is the 2 pi r, sorry, 2 pi r is, r here is not the 12, this is equal to 12 half is equal to 6, right? Meaning the 6 is 6 exponent -2, right? And the next is sorry, 6 is not the distance between the two wire. The distance between the two wire is 12. So again, it's not the value of the r here. So meaning the value of the, this is the distance between the two wire is let's say this is D, it is D first, the distance between the two wire. So nu naught is constant, 4 pi exponent minus 7, and the I1 is 3.5, and the I2 the same magnitude, 3.5, and the distance is 12, not 6 centimeter. 12 is what to the centimeter is exponent minus 2, and now you can find the force per unit length is equal to 2.0 exponent minus 5, because this is unit force newtons, and per meter, unit for meter is a unit for the length is a meter, or newton per meter, force per unit length. Next question, figure 6 show an electron traveling in a radial uniform electric field. So you have electric field here, so this is a positive plate. This is a negative plate. You have a magnetic field. So this is electric field E, and this is magnetic field B. So now you have combination magnetic field and electric field. So this is electron, and negative charge or electron enter to the regions consists of E and B, right? So meaning this is electron, meaning when the electron enter to the plate, positive and negative, the direction of the electron or electric force acts on the electron, because this is negative, the direction of the electron attract to the positive, because electron is a negative. And if you have the magnetic field in the area here, so if you use the right hand, so the force, electric force acts on the electron is given by the equations QE, right? This is chapter 2, and the force, magnetic force, acts on the charge, because you have a magnetic field here. Magnetic force acts on the electron is given by the QVB, and this is the same value here. So meaning you have a FE is equal to FB, so this is equal to QE is equal to QVB. So now the V here, the speed, is equal to E over B. So I write that here. This is a velocity of the charge is equal to E over B. So now the question number 1, velocity of the electron here. So now the value of the E magnetic field, electric field is 3.9 exponent 4. And the value of the B is 6.5 exponent minus 2 Tesla. So now you can find the value of the V is 6 times 10 power 5 meter per second. This is the high speed, 6 exponent 5 meter per second. This is question number 1. And number 2 is calculate the kinetic energy of electron. To calculate the kinetic energy, this is number 2. Number 2 is kinetic energy, or KE. Kinetic energy is given by the equation kinetic energy half mv square. And the mass, this is an electron, so the mass of the electron is this constant values 9.1 exponent minus 31 kilogram, and the speed from the answer number 1, 6 exponent 5 meter per second. So you can find the kinetic energy is equal to 1.64 exponent minus 19, because this energy unit is joule. Number 3, if the electric field is removed, so now you can remove the electric field. Now you have only the magnetic field B here, right? Magnetic field B here, right? The question asks you calculate the magnitude and direction magnetic force on the electron. So as you know, the equation to calculate the magnetic force of FB is equal to QVB, and the Q is electron charge, Electron charge is 1.6 exponent minus 19, and with the speed, yeah, you can use the value, the speed here, the speed of the answer here, 6 exponent 5 meter per second. And the value of the b, yeah, b is given by the question is 6.5, right? 6.5 exponent minus 2, and the final answer for the b, so I write here magnetic force x on the electron when the electric field is removed, F is equal to 6.24 exponent minus 15 Newton. And direction, so what is direction? So to find the direction here, you can use the, because this is electron, this is a negative charge here, so you must use your right hand, and your finger, your thumb is direction of the force, and the first finger is direction of the B, and the second finger is your hand, right? So this is the force and this is the speed of the electron, so meaning all the item here, force B and V is 90 degree, so B direction into the page and V direction to the downward, yes, the force direction to the left. That's all, thank you.